Okay, yesterday we talked about the law of sines, just kind of the workings of it, that it's a proportion of an angle and its corresponding side length, that sort of a thing. Today we're going to talk about situations called the ambiguous case. All right, every one of these problems on your test, on the practice that I'm putting together, all the stuff, it's going to say, using the law of sines, solve. If there is no triangle present, state so. If there are two triangles present, find the measures of all the triangles. So we have to assume, going into all of our law of sines problems, you have to assume that there's always going to be two triangles. All right, so I wrote that right here. Always assume that two triangles are present. Whatever angle they give you, if they give you two angles, you just add those up, subtract from 180. If they give you two angles, there cannot be a second triangle present. But if they only give you one, there mathematically could be a way for two triangles to be formed. So what you're going to do is always assume that there's two triangles and write down the given angle in both triangles. And I'll show you. We're going to go through a bunch of these. These are different scenarios in where there is or possibly could be an ambiguous case, just if you guys want to look at that. Again, if we're looking on your test, it's going to say, using the law of sines, solve. It's not going to say one solution case. I mean, they're telling you here there's only one solution. So we're going to do these three examples of one solution, no solution, and two solutions. And then I have two additional examples that I want to go through to make you guys understand the process of trying to figure out if there's no triangles, one triangle, or two. So using law of sines, that means I go ahead and set up and I say, okay, there's a possibility of two triangles. So I'm going to say triangle 1 and triangle 2. Get that set up in your mind every time you have a law of sines problem. What is the angle that is given to us? Angle A. So I'm going to write here, angle A is 42 degrees. Now, if angle A is 42 degrees in triangle 1, if there is a second triangle, angle A will be 42 degrees in that triangle. All right? Everybody with me? All of the given stuff will be the same if there's two triangles. So A, B, and C. So given is 42 degrees, A is 10, and B is 7. Did I write all that information correctly? 42 is across from 10. Side C is across from angle B, correct? So let's figure out what we are missing, what we're going to have to solve for. I have to solve for angle B, angle C, correct? Angle C, and then side C, agree? So if there's two triangles, I have to find that information as well. Angle B, angle C, and side C. Now, to find out if there's two triangles, guys, it's one tiny extra step. That's it. So we'll look at that in a second. So I go here and I say, all right, what is the proportion that I have already set up for me? An angle measure and its corresponding side length. Sine 42 over 10, right? You guys agree? Okay, so then I'm going to find what? Can I find anything about C right now? No. So I have to find something about which angle? B. So I'm going to say sine of B over 7. So how did we do this yesterday? Cross multiply. So you have 7 times the sine of 42 equals 10 times the sine of B. Divide both sides by 10. And you get the sine of B equals. I don't need to know what the sine of B equals. I'm looking for the actual measurement of B. So you have 7 sine 42. Make sure you close that parenthesis. Divided by 10. And you guys get a little decimal, 0.46839. I told you yesterday, hang on a sec, you don't have to write that decimal down. What you can do is hit second sign, second answer in your calculator, and you come out with what? When y'all do that in your calculator, second sign, second answer, what do you get? How big is this angle? About 28 degrees. Agreed. So I found out here that angle B is about 28 degrees. So I'm going to come over here into my triangle and say, in the first triangle, angle B is about 28. Now, this is where you have to figure out if there's a second triangle or not. You are given an angle, right? Then, once you get your given information, you found an angle, correct? We found B. Whatever angle you find, whether it's B or C, depending on the information they gave you, whatever angle you find the supplement to it. What does the word supplement mean?
Other side.
Okay, what do you mean by other side? Like 180, good. Supplement means when I add two angles together, I get 180. So I'm going to say 180 minus 28. So 180 minus 28. You guys will see why in a second. I get 152 degrees. Okay? Now let's finish solving triangle 1. Let's go over here to triangle 1. How would I figure out in triangle 1, how would I figure out what angle C measures? You add 42 and 28. So 42 plus 28. I get 70. So I say 180 minus 70 and I get 110. Agreed? Okay. Well, now let's figure out if a second triangle exists. I'm going to do the exact same thing over here, guys. I'm going to add 42 and 152. So 42 plus 152 and I get 194. Can I say 180 minus 194 and get a positive number? No. If the two angles in the second triangle add up to be bigger than 180, then a second triangle does not exist. That's how you guys would show me that. And then you just finish your problem. You have to find side C. Well, the original formula, the original proportion we used was sine 42 over 10, right? So sine 42 over 10 equals, in the first triangle, triangle 1, how did we find, what did we find the measurement of C was? 110. So sine of 110 over C. How do we solve this? Cross multiply. So sine 42 times C equals 10 times the sine of 110. How do I get C all by itself? I divide by sine 42. And how long is C? About 10 times the sine of 110. Hang on one sec. Divided by sine 42. About how long? 10. So it's about 14. It's 14.04. So about 14. So on your test, right, you always assume that there's two triangles. This would be you showing all of your work. You'd be showing me that there is only one solution. The reason why there's only one solution is because there's not enough extra degrees left over to create a second triangle. Christian. All right, guys, we're going to assume that there's two triangles. So we get our problem set up that there's two triangles. The given angle is 43.1, so I wrote it down for both triangles. And then I drew myself a little picture. What are we missing? What are we going to have to solve for? Angle B we're missing. What else? Angle C and side C. So I'm going to write that down. I'm going to say, okay, I have to find angle B. I have to find angle C and side C. If there's two triangles, I will have to find that information in both. Angle B, angle C, and side C. Okay? Yes. All right, so what proportion do I already have? Did they already give us? A. I already know that I have the proportion of sine 43.1 over 186.2. Again, the numbers are bigger. That doesn't mean anything. What do I know something about? Angle side C or angle inside B? B. So that means I'm going to find angle B first here. I have to find B first because that's the only other thing that I know any bit of information about. So how do we solve this again, guys? Cross multiply. This is good practice. 186 times the sine of B equals 248.6 times the sine of 43.1. Divide both sides by 186.2 because we want to get sine of B by itself. And I get the sine of B equals. Do that in your calculator. Okay, you guys should be getting like 0.91224, something like that. Okay, so in your calculator, that's fine. Just hit second sign, second answer. And it'll come up with a decimal equivalent. Round it to 1 decimal since they gave us one that was rounded to 1 decimal.
Can we leave it like that?
65.8.
Well, can I just leave it like that?
No, don't round out the whole thing.
Okay.
Round it to 1 decimal place. So 65.8.
So, second?
So you guys should be getting that angle B in triangle 1 is about 65.8 degrees, correct? All right, so up here, I'm going to go and I'm going to say angle B is 65.8 degrees. So to see if there is a second triangle present, we have to take the first angle that we find, right? We were given one, now we're going to take the first angle that we find and find the supplement to it. So 180 minus 65.8, 114.2 degrees. Okay. All right, now, if there is a second triangle, we will be able to find that out right this second. Let's go through. Let's finish the first one. How do you find the third angle in the first triangle? What do you do with these two numbers? Add, so 43.1 plus 65.8. I get 108.9. So 180 minus 108.9. 71.1. Okay. So over here, same thing. I'm going to add 43.1 plus 114.2. And I get 157.3. Can I take 180 minus 157.3 and get a nice positive number?
Yes.
Absolutely. 180 minus 157.3. I get angle C here is 22.7 degrees. So with the information that they gave us, it is mathematically possible that two triangles exist. So now I have to figure out C in both triangles. I'm going to use the proportion that we used from the very beginning that had to do with A, that they gave us. So I'm going to say, okay, well, the sine of 43.1 over, was it 186? Yeah, 186.2 equals the sine angle in triangle 1, angle C is 71.7, and then I have over C. In triangle 2, use that same proportion, sine 43.1 over 186.2. That was given to us at the very beginning. And then we're going to use angle C from triangle 2, so sine 22.7 over C. And then how do we solve this, guys? Cross multiply, so you have 186.2 times the sine of 71.1 equals C times the sine of 43.1. How do you get C all by itself? Divide by sine of 43.1. Sine 43.1. And I get C equals about how much? Okay, so C is 257.819. So we'll round it to 1 decimal place. We'll say that C is about 257.8 in triangle 1. And we do the exact same thing in triangle 2. Cross multiply, so 186.2 times the sine of 22.7 equals C times the sine of 43.1. Divide both sides by 43.1. And over here, C equals, I got 105.163. So C here is about 105.2. So do you guys understand? It's one extra step to see if there's a second triangle. You find the supplement of the first angle you find. You have an angle given to you. Then you find an angle. Then you take the supplement of that. If when you add that together, the sum is less than 180, then a second triangle is present. And then you have to solve for the missing sides in both. Question. All right, let's go to the next example. All right. Again, I understand it tells you there's no solution, but just work through this with me. Using the law of sines, that means we have to assume there is what? Two triangles. So let's go ahead and set our problem up. Assume there's two. What is given to us? Angle A. So angle A in triangle 1 is 42 degrees. That means angle A in triangle 2 is how much? 42 degrees. Good. So let's draw ourselves a picture so we can figure out what we're missing, what we need to find. So A is 42. Across from A, side A is 70. Across from B is 122. So what are we missing? We're missing angle C, angle B, and side C. So I need to find angle B, angle C, side C. If there's a second triangle, I will have to find that over here as well. Did they already give us a proportion to use? Yep, they already gave us an angle measure and its corresponding side length. So sine 42 over 70 equals, what do I have to find first? Why B? Because I have a corresponding side. I know nothing about C. I don't know sides, I don't know angles. So to solve this, we do what first? Cross multiply 122 times the sine of 42 equals 70 times the sine of B. Divide both sides by 70. So sine B equals, I'm getting 1.166199. Remember, you don't have to write that out. All you need to do in your calculator is know, oh, I have to do the inverse of that. I have to do second sine, second answer. And what does your calculator say? Error. Your calculator tells you, wait, this is impossible. So how many triangles are present here? None. You would say no triangle. You can leave it just like that. You can cross them out if you want to. But you're showing me here that you did the proportion. You set it up. You figured it out. But mathematically, it is impossible that a triangle is formed. So your possibilities when using the law of sines is either one triangle is present, two triangles are present, or no triangles can be formed. Does that make sense? Because when you do this mathematically in your calculator, the sine of 1.16 cannot be determined. You get error in your calculator. We're going to do these two together, and then we're done. Yes, ma'am.
If it's not good enough, then there's no triangle.
Using law of sines, so we're going to get our picture set up here. I'll do it above so we have room to do some work. I'm going to assume there's how many triangles? I'm going to assume there's two. So 1 and 2. What is given to us in number 11? Angle A. So they gave me angle A is 70 degrees. If they gave me angle A is 70 in the first one, and if there is a second triangle, then angle A will be 70 in the second one. So let's draw a quick little picture and see what we're missing. Some of you like to write down A, B, and C. That's fine. I just like to write down what's given and then figure out what we're missing. I think that's a little better to do, and you'll see why in a second. So A is 70 degrees. Across from A is 25. Across from C is 26. So what are we looking for here? We're looking for B, right? Angle B. We're looking for angle C, and we're looking for side B. So a little different here. We're looking for angle C. So that would be in both. We're looking for angle B. That would be in both. And we're looking for side B. That would be in both. Whatever angle and side length that we're looking for, I put together in my list. Do you guys see how we're looking for B and we're also looking for side B? I always put them together because once we find our given, the next thing we find, we're going to have to use as a supplement. Yes, sir. So here we go. I'm going to look here and say, all right, well, what's going on here? What do I need to find? What do I need to do? Let's find C. So look for C. What proportion do I already have? I already have the side and angle measure for A. So I have sine of 70 over 25 equals sine of C over 26. Agreed? Okay, what do we do? Cross multiply. So 25 times the sine of C equals 26 times the sine of 70. Divide both sides by 25. And I get the sine of C equals, all right, so 0.97728. So now hit second sine, second answer, and you get that angle C, rounded to the nearest whole number. 78 degrees? Okay, 78 degrees. So if we find here, in this triangle, that C is 78 degrees. How do we figure out if a second triangle is present?
Add them together. Subtract.
Add what together?
Add 70.
That just is going to find the missing angle in the first triangle. How do I figure out if there's a second triangle present? I got to find the supplement here. 180 minus 78. What is 180 minus 78? 102, okay? 102 degrees. Now, to find angle B, to find this angle here, the last one, I say 70 plus 78 is 148. So 180 minus 148 gives us how much? 32 degrees. Okay, that's fine. So over here,
How do you get those now?
how'd I get what?
The angles, the measures and stuff.
Which measure?
For angle C.
C, we just did in our calculator. Right here.
No, wait, I'm sorry.
Angle B, I added 70 and 78 and got 148, and then I did 180 minus 148.
Wait, but why add 70 again?
Because there's 3 angles in a triangle. So one of the angles is 70, one of the angles is 78.
Okay.
So you add those two and then subtract from 180. So on the right-hand side, guys, if you add 102 and 70, do you get a number that is less than 180? Yes. I got 172. It's not much smaller than 180, but it is smaller. So are there available degrees left over for a third angle? Yes, 8 of them. It's a tiny little angle, but that's okay. So how many triangles do we have present in this scenario? There's 2. And now we need to find B in both of them. So I'm going to use my original proportion, which I use sine 70 over 25. So sine 70 over 25. For triangle 1, if I know that angle B is 32, so sine 32 over side B. For triangle 2, I'm going to use that same proportion. I'm going to say sine of 70 over 25. But instead of 32, I found out that that angle was 8 degrees. So it's sine 8 over B. And in both cases, we're going to cross multiply. So 25 sine 32 equals B times the sine of 70. Divide by sine 70. So in triangle 1, B is about how long? Right? So I got B is about 14. Did you get that?
Nope.
So in triangle 1, I got B is about 14. So let's look in triangle 2. Let me see again. So over here, we're going to do the same thing. Where'd it go? We're going to cross multiply. So 25 sine of 8 equals B times the sine of 70. Divide both sides by the sine of 70. And in triangle 2, how long is B? About. I got 3.7. So if we're rounding to the nearest whole number, we'll say around 4. Good. So guys, how many triangles did you prove were present in this case? 2. Can I give you 15 of these problems along with 10 other problems to do on a test? No. I mean, you probably have 1 or 2 of these. I doubt both of them will have 2 solutions. They may not, none of them may have 2 solutions. But just get in the habit of always assuming there's what? When you have law of sines, you always assume there's how many triangles? 2. So let's do this one and then we're done. Angle 1 and triangle 2. Always assume there's 2 triangles. What is given to us? Oh, finally, they didn't give us A. So angle B is 45 degrees. So we assume that if angle B is 45 in the first triangle, then if there is a second triangle, it has to be the same in that second triangle. So draw yourself a little picture. A, B, and C. 45 is up here at the top. Across from angle A is side A, that's 28. Across from angle B is side B, that's 27. Do I have my proportion that I can use for my law of sines? Yes, I have sine of 45 and I have side 27. So I'm looking for side A and side C. And I'm looking for angle A, angle C, and I'm looking for side C. So I have to find angle A. That's the first one I'm going to find. Then C, then little c. So A over here. C and little c. So here we go, ladies and gents. We just said a second ago that our proportion was the sine of 45 over 27 equals sine what? Sine of A over 28.
put it other way around? Be the same thing?
Meaning what?
Like you first put sign A of 28.
Yeah. That's fine. So cross multiply 27 times the sign of A equals 28 times the sign of 45. Divide by 27. And you get the sine of angle A is about how much? 0.73329. Second sign, second answer. About 47 degrees. So measure of angle A. That doesn't look like measure. Measure of angle A is about 47 degrees. So if I say that A is about 47 here, how do I figure out how much A is in my other triangle, if there is one? Subtracted by 180. Good, Christian. So I have 180 minus 47. 180 minus 47 is 133. degrees. Everybody with me? We're okay? All right, let's finish the first triangle. If the first two angles are 45 plus 47, that gives me a total of 92. All right, so I say 180 minus 92, and I get 88 degrees. Everybody okay with that? Yes, we're good? All right, on the right-hand side, I'm going to add 45 and 133. It has to be less than what? 180. It's 178. Is that less than 180, guys? Yes. Is it a huge angle? No, it's a teeny tiny angle, but there are 2 degrees left over, so a second triangle can mathematically be performed. Now, all I'm asking you to do here is finish this up and just find the corresponding side C in both triangles. So I'm going to go back to my original proportion that I used, sine 45 over 27. I'll do it down here. Sine 45 over 27 equals the sine of 88 over little c. And then I'm going to use that same proportion, sine 45 over 27 equals the sine of 2 over little c, right? You guys agree? Okay, so then just cross multiply. So 27 times the sine of 88 equals c times the sine of 45. Divide both sides by sine 45. And side C is about 38.16, so we'll say 38.2. We can just say 38, we'll round to a whole number. So this one is about 38. And then over here, same thing. Cross multiply. 27 times the sine of 2 equals c times the sine of 45. Divide by sine 45. And c equals 27 sine 2 divided by sine 45. 1.3. So it's about 1. It's a teeny little side across from a teeny little angle. But, guys, what did you prove? How many triangles are present? 2. So when you have a problem that says using the law of sines, you need to assume that there's always going to be 2 triangles. The situation will arise that there's either 0 triangles, 1 triangle, or 2 triangles. And if there's 2, you got to solve for everything that's missing. Sound good? You guys are really good today. Thank you.